definition of a rectangle is a quadrilateral, so four-sided, with four right angles. So, four right angles. Okay, that's the technical definition of a rectangle. Now, the technical definition of a rhombus is a quadrilateral with four congruent sides. Oh, really? There we go. So we have 1, 2, 3, 4 congruent sides. And then it doesn't matter how they're rotated. That's definitely not a rhombus. And it doesn't matter anything about the angles. All we care about is the sides. Okay, so all four sides are the same. Now, a square is a quadrilateral with four right angles and four congruent sides. So squares are a rectangle and a rhombus at the same time. Okay, so with a square, that's not a square. Still not square. There we go. We have four congruent sides and four right angles. Okay, so every square is a rectangle, but not every rectangle is a square. And every square is a rhombus, but not every rhombus is a square. Because the rhombus angles can be kind of anything, as long as the sides are all the same. Whereas a square has to be 90-degree angles, just like a rectangle, 90-degree angles. Like to do a little Venn diagram? If we have rectangles here and rhombuses here, when a rectangle and a rhombus have a baby, it's a square. All right, the diagonals of a rectangle are congruent. So if we have a rectangle, and then we put the diagonals in, so if this rectangle is ABCD, AC will be congruent to BD. Okay, so these two lines are the same length as each other. And if we have a rhombus, not a rhombus, close enough. If we have a rhombus, the diagonals are perpendicular to each other. Let's say this is E, F, G, H. F, H, perpendicular to EG. So far, okay? In a rhombus, not even close to a rhombus, not even a quadrilateral. There we go. In a rhombus, let's make that bigger. The diagonals bisect the angles. So when you come through, we have that they're perpendicular, but they also bisect. So this angle gets cut in half, this angle gets cut in half, and this angle is cut in half, and this angle is cut in half. So the diagonals are perpendicular bisectors. No, sorry, I can't call them perpendicular bisector. I'm lying. They bisect the angle, not the, we don't have that yet. If a parallelogram has a right angle, it has to be a rectangle. Okay, so remember what we have in parallelogram is that this angle is congruent to this angle here and here, and then this angle is congruent to this angle. Well, and this one plus this one is 180. So if this one is 90, then this one has to be 90 because they're congruent. And if these add up to 180 and that's 90, then that makes this 90. And that makes this 90, which means we have all four 90s. So as soon as you get 190, they're all 90. If it's a parallelogram. So far okay? If a parallelogram has two adjacent sides congruent, then it's a rhombus. Because remember we talk about parallelogram, this side is congruent to this side, and then these two sides are congruent. Well, if we have adjacent sides, so this side is congruent to this side, adjacent means touching each other, right? Well, and then this one makes this one congruent, and that one makes that one congruent, then they're all congruent. So it's forcing everything to match. Good? Okay. All right. Here are a summary of the properties. Every rectangle is a parallelogram with four right angles and congruent diagonals. Okay. We also know that with a parallelogram, the diagonals bisect each other, which means that all four of these lengths in a rectangle are the same. Every rhombus is a parallelogram with four congruent sides and perpendicular diagonals, which bisect the angles, but also we know that in a parallelogram, diagonals bisect each other. So this will be the same as this, and this will be the same as this. So the diagonals are also perpendicular bisectors to each other. So far okay? And then this angle is the same as that, and this one is the same as this. And then this one is the same as this, and this one is the same as this. Okay. And then in a square, all of this is true. Because when you're a square, you're both a rectangle and a rhombus. So every property for a rectangle is true, every property for a rhombus is true, every property for a parallelogram is true. So you have 4 90-degree angles, 4 congruent sides, perpendicular bisecting diagonals that bisect the angles. So when we cut in with the diagonals here, they become 90 degrees and these become 45s. And then all four of these lengths are the same. So you get all the properties all in one nice little square package. Now, we want to find the coordinates to make this a rhombus, which means I need this length to be the same as this length and this length to be the same as this length. I can test that these two are, well, once I get through this, I can test that everything's the same length by counting. So I'm going to go from a -2, or sorry, from a 1 to a 6. To go from a 1 to a 6, I move 5 spaces. So I want to move 5 spaces here as well. Okay, so -2 plus 5 is 3. Okay, and then to go from a 3 to a 7, I move 4 spaces. So I want to move 4 spaces down here. So 7 minus 4 is 3. Now I can tell you already these two are the same length because I made them that way. And now this one being the same length straight down as here straight down, I make a right triangle. So that makes the hypotenuse the same length. So this is the coordinates to be a rhombus. So far okay? So ABCD is a rectangle. EDC is 37. What I know about rectangles is that all the corners are right angles. So I know they're going to add up to 90. So I do 90 minus 37, which is 60 minus 7, which is 53. Good? HIJK is a rhombus. LKJ is 29. And I want to find HIL, which is this one right here. But I know that bisecting diagonals, so I know that this one is the same as this one, which is the same as this one, which is the same as this one. So if this one's 29, that one is also 29. Good? Okay. MNOP is a square, OQ is 17, and I want to find MO, that's this whole length, and I know that this is half, so multiply it by 2, and MO is 34. And finally, we've got a rectangle. So -9, -5, -9, 1, -4, 1, and then I want to find the missing spot. Well, it's a rectangle, so my x's have to match. So I have a -9 and a -9, so I need a -4 and a -4. And then my y's have to match. I have a 1 and a 1, so I need a -5 and a -5. So far, okay? If it had been a rhombus, I would have done the counting spaces thing. But because it's a rectangle, I know we're flat and flat and flat and flat, so I needed to match the missing x and the missing y. Because I was going to have 2 x's here and 2 x's here, 2 y's here and 2 y's there. Good? Rectangles and rhombuses and squares are nice, yes? You can also say rhombi if you don't want to say rhombuses. They're both actually grammatically correct. It's one of those weird things. Okay, we're going to skip that. I'm going to skip this. And we're going to move on to trapezoids. Okay. A trapezoid is a quadrilateral with exactly one pair of parallel sides. That's the top and the bottom. Or if it's sideways, the two sides. The bases are the parallel sides. The legs are the non-parallel sides. And then the base angles are the pairs of angles formed by the base and the leg. So we have 2 sets of base angles here. So these are base angles 1 set. And then I have base angles here. And I'm using different number of lines because we don't know, yeah. Okay, so I have 2 sets of base angles at the top and the bottom. If I have an isosceles triangle, the legs are the same. Basically, it's like you had an isosceles, I said triangle, didn't I? Isosceles trapezoid. If you took an isosceles triangle and you chop the top of it off, you get an isosceles trapezoid. So the legs are congruent. And then there's something called a median, which joins the midpoints of the 2 legs. So here and here we have midpoints. So that makes these 2 lengths the same as these 2 lengths are the same, and then these 2 lengths are the same. If this is an isosceles trapezoid and then you have a median, all 4 would be the same. So I'll draw that real quick. There. Okay, so far okay? Each pair of base angles in an isosceles trapezoid are congruent. So if these 2 legs are congruent, then these 2 angles are congruent, and these 2 angles are congruent. And that only occurs in isosceles. It doesn't occur in any other trapezoid ever. If you have just any old regular trapezoid, nothing is congruent angle-wise. Okay. If you have an isosceles triangle or trapezoid, the diagonals are also congruent. So AC would be congruent to BD. No, we don't, there's nothing, like they don't bisect each other at all. They're just intersect. because it's a trapezoid, not a parallelogram, so that it shifts up. What we do know, though, is that these two will be the same, and these two will be the same, only because it's isosceles. Okay. The median of a trapezoid is parallel, so all of these three lines are parallel. And its length is 1/2 of the length of the top and bottom added together. So, for example, if AD is 10 and BC is 6, XY would be 1/2 of 10 plus 6. So it's half the length of the top and bottom added together. So here I have a regular old trapezoid, not an isosceles trapezoid. But because this is a median, I know this length is the same as that length, and this length is the same as that length. That's really all I know. LM is 8, so I'm trying to find PM. Well, it's halfway, so I divide it by 2, PM is 4. So far, okay? All right, so BC, we have an isosceles trapezoid. That tells me these are the same as all each other. BC is 34. BC, 34. So I want to find FC, that's half of it. So I divide it by 2, it's 17. Angle ADC is 59. BCD, well, because we have an isosceles, we know these two are the same. So that's also 59. Now what we didn't talk about, let me label this. Because this is isosceles, these are the same as each other. This angle is the same as this angle, which is the same as this angle, and the same as this angle. Because we have parallel lines with a transversal, and these would be corresponding angles. So we go back to that parallel line thing, and these would be in the same position. And then this angle is the same as this angle, which is the same as this angle, which is the same as that angle. And then the same things hold true. Red and green would add up to 180. So these two would add up to 180, this one and that one, this one and this one, you know, any red and any green would add up to 180. Now in a regular trapezoid that's not isosceles, you get sort of the same thing, but it only occurs on one side. So blue and blue, red and red, but they don't match the other side. On the other side we'd have green and, say, purple. Make sense? Okay. Right. If AB is 16 and DC is 24, so I have the two bases, and I want to find the length of the median, it's 1/2 of the two bases added together. So that's 1/2 of 40, so 20. And then DAB, that's this green one right here, is 109. DEF is this red one right there. No, DEF is this green one right here, sorry. DEF, not AEF. So I have two green ones, so they match. So that's also 109. If I wanted to find AEF, I would have taken 180 minus 109, which is 71. Also, if I was given, say this is 10 and this is 23, and I want to find this length, well, we'll just call that x for right now, and I know that 10 would be equal to 1/2 of x plus 23. because the median is half of the 2 added together. So to solve this, you want to multiply both sides by 2 first. And then, well, that was just bad math. Let's make that not 10. Oops, too big. I just made a bad example, that's all. We'll make it 15. So that makes that 30. Subtract 23 from both sides, and you get 7. Okay, so without algebra, multiply this by 2 and subtract the other one that you have. Yeah, so you do the median times 2 minus the base gives you the other base. So if you have the 2 bases, add them together, divide by 2. If you have the middle and one side, multiply the middle times 2 and subtract the one side to get the other side.